Okay, these questions, these three Grignard questions, are actually quite complicated because there's several possible answers to each of them. So it just depends which end your carbonyl group was and which end your Grignard reagent was. So essentially here, either we can, this can be the new carbon-carbon bond we've created. If that is the case, then the Grignard, sorry, 1, 2, 3. That's not quite right. Sorry about that. Okay, 1, 2, 3. In which case that would have been my aldehyde, and my Grignard reagent then is just going to be the methyl magnesium bromide. Okay. Or my this could have been, I could have formed a new carbon-carbon bond here in this position here. So in that case, so that's one set of options. Another set of options would be this, where I've got 1, 2 carbons. At the end of this carbon, I would have my magnesium bromide. So I've got, would be, according to this numbering, carbon 2 and carbon 3. Okay, and then that carbonyl group, that carbonyl group would be there and attached to there, and that would be carbon atom number 1. So it just depends where which is the new carbon-carbon bond that you're going to form. This is the more probable format because it's easier to make. It's just more likely that your carbonyl group is on the more complex part of the molecule, but it's not necessarily so. Okay, the next, so that's just to say there are 2 possible solutions there, so just be careful about that. This reaction here, again, it's a little bit more complex, so I'm just going to put it in the middle, and then we're going to look at the 2 options. Actually, this one only has 1 option because there's only really 1 new carbon-carbon bond that could have formed. In all likelihood, there's another option, but it's a very, very unlikely option. So this is the most probable bond that's going to have been formed, and in that case, my this must be my starting material. Okay, my carbonyl group that oxygen carbon bond must be in place, so that must be my carbonyl group, and then this 1, 2, 3. 1, 2, 3 carbons attached to magnesium bromide. Okay, that's most likely. There is a very, very, very small possibility that this could have all come from a single atom, a single compound where this could have broken. But in fact, given the structure of the question, where it clearly shows you that you would have had 2 starting materials, the other one, the intramolecular reaction, is not actually given as an option here. Okay, the third option, the third question, this part shows OH, and this one is super tricky, because in fact there are 3 potential new carbon-carbon bonds. If that was my new carbon-carbon bond, then this would have been my carbonyl compound. Okay, that's my new bond formed, so that must have been my Grignard reagent. And remember, you've got to make sure that you've actually got a carbon atom there, because there's a carbon atom there. Okay. Likewise, that could have been my new carbon-carbon bond formed, in which case this would have been, let's just draw this like this. This would have been my carbonyl compound, and I would have had ethyl magnesium bromide. Would have been the second half of that, or I could have had that, which is very similar, except that let's just draw it like this so you can see which one I'm doing. So that's the one, but notice I've just got 2 carbons there, and I'm adding 3 carbons into my chain, so in which case I've now got propyl magnesium bromide. Okay, so but those pairs must go together. Okay. As long as you've got both, you can't mix and match. The pairs go together. Okay. And then simple reduction reaction. Where did this come from? H. Where did that come from? Well, that must have come from this. And I could have used, in order to get that, I could have used lithium aluminium hydride. 1, 2. I could have equally used sodium borohydride. Doesn't matter. Second one, let's say we use sodium borohydride for this one. Okay, and that must have again come from the ketone. Oops, sorry, I need to put in aqueous acid there. Okay, so again, particularly with the Grignard reactions, you've got to count your carbons. It's very, very, very easy to make a mistake with those reactions.